Welcome to our discussion on conversion lines. Conversion lines are a very simple technique for converting any unit of measure. It can be a single unit of measure. Let's say you want to convert from inches to centimeters, or feet to kilometers, or it can be what you can think of as compound or what might seem more complicated units of measure, like miles per hour to feet per second, or miles per hour to kilometers per hour, or how about meters per second squared to feet per second squared. All of these things can be converted, liters to gallons, any unit of measure to any other unit of measure, whether it's a singular measure or a compound measure. They can all be handled very easily with a conversion line. And all it is simply is one big fraction, right? Because to remind ourselves why this works, if you have 3/4 times, let's say, 5/7, remember you just multiply straight across and you get 15/28, right? Well, what if you have something like 3x, let's make this 8x squared over y times, how about 3y over 2x. Well, again, you can just multiply straight across and get 24x squared y over 2xy, and then look at this and reduce and go, oh, wait a minute, that's 12x, right? Because the y's cancel and you get 1x and then the 12 and 24. Or you can reduce before you go, right? You can go, okay, well, this x squared becomes an x and gets rid of that one, and then this 2 reduces this to a 4, and then the y's cancel, and I'm left with 4 times 3 is 12, and I still have that x, and I get the same thing as 12x, right? So when you're multiplying fractions, you have to remember that you can reduce as you go, or you can reduce at the end. It really doesn't matter. But the conversion line is just treating your units of measure as these variables. So for instance, here's a simple example. Irma's up in Canada. Gas up there sells for $1.45 per liter, and that's in Canadian dollars. And if the current conversion rate is $1.08 US is equal to 1 Canadian dollar, and we know that 3.785 liters equals 1 gallon, we can now figure out what the cost of gasoline is in Canada in US dollars per gallon, the thing that we're used to, right? So with the conversion line, just remember, think of this as one big fraction, right? So just like these fractions here, you just need to fill it in top and bottom with your first fraction. Well, my first fraction is this price. And so you want to set up your first fraction with $1.45, and I'll put a little CA so we know that's Canadian dollar, is 1 liter, LTR. And that's my first fraction, right? Whenever it's something per something, that's a fraction that's over $1.45 per 1 liter. Okay, now we know that our answer, when we get over here, we want it to be in US dollars per gallon. So that means we need to be canceling things out until we're left with a US dollar and a gallon. Okay, well, we've got a liter on the bottom and we need a gallon, and we've got this bit of information right here. So we know that we have this relationship that 3.785 liters is equal to 1 gallon. Well, that means if I divide both sides by 1 gallon, then doesn't this just equal 1? So this fraction is now equal to 1. So if I come over here and I put 3.785 liter over 1 gallon, this fraction is equal to 1. So if I multiply these fractions, I haven't changed this amount, right? It's like taking 1/2 and multiplying it by 10 over 10. 10 over 10 is still a 1. And 1/2 times 10 over 10 gives me 10 over 20, which is still 1/2. It just looks different. And that's all that's going to happen here. And now these liters cancel, right? Just like this y and this y would cancel. The liter and the liter would cancel. And now if I do this multiplication, I'll have some number in Canadian dollars per gallon. But I don't want Canadian dollars. I want US dollars. So I need to use this last conversion, and since I need to get rid of Canadian dollars up here, I need Canadian dollars down here. So I have $1 dollar Canadian is equal to $1, sorry, let me write that better, $1.08 US. And now, just like before, the Canadian dollars cancel, and if you do the math, 1.45 times 3.785 times 1.08, you do all that, you get 5.93, and then what's left for unit of measure, right? The Canadian dollar's gone, liter's gone, the only unit of measure left is US dollars, so this is $5.93, right, US. And on the bottom, 1, 1, 1, we have 1 gallon, and we now see that the cost of gas in Canada is $5.93 per gallon. Okay, let's take a look at another example. Okay, here's a second example. We've got an espresso machine that dispenses espresso at a rate of 0.38 milliliters per second. They want to know how much time in minutes, right, will it take to fill a 3 fluid ounce cup with espresso. And they give us some information knowing that 1 fluid ounce is equal to 29.5735 milliliters. So we have all the information we need, and now we need to figure out, all right, where do we go with all this? Well, you need to identify the question. The question is, how much time? How much time in minutes will it take to fill? So we know our answer is going to be time. We recognize that we're given a rate, and we're given a volume. And so maybe we remember that, okay, well, a distance equals rate times time, but so does a volume will equal rate times time, right? A volume will equal how fast something is filling times how long you let it fill. That will give you your total volume. Well, we're given a volume, we're given a rate, and this is the question. This is what we're looking for. So really we need time all by itself. So volume equals rate times time when this is what we're looking for. We want to solve for time, so divide both sides by rate, and we have volume over rate equals time. Or you can think of it as volume times 1 over R, right? Because if you divide by rate, you're just multiplying by 1 over its reciprocal. Now, you don't really need to remember all of this because the conversion line helps you. Start with what you have and figure out how to get to where you need to be. They gave you a rate, right? The first thing they gave you was a rate. And you need to solve for time. They gave you ounces, right? They give you this. You can start with whatever you want and you'll figure it out. We know that eventually we need time. And we need that time in minutes. So we need to somehow finish with time. Okay, if you're still not seeing it, think of a simple example that I know you can solve in your head. Let's say you're filling a hot tub with a hose, and the hose has a fill rate of 5 gallons per minute, and your hot tub is 500 gallons. And the question is, how long? All right, how many minutes? And you go, well, duh, right? 5 gallons per minute, I'm going to need 500 gallons. Then it's going to be 100 minutes. Because you can do that in your head. You can figure 5 gallons a minute, 5, 5, 5, 5, it's going to happen 100 times. But really, what's the math involved in that? Well, you've got, there's my volume, 500 gallons, right? Times, I know here, volume times 1 over rate. But regardless, I know that my answer is going to be in minutes. So I need something to have minutes here, and then I need gallons down here, so these cancel. So instead of 5 gallon over minute, I get 1 minute over 5 gallons. And now I do the math, 500 divided by 5, and there's the 100 that you guys already knew was the right answer. We can use that same kind of idea here, and we can start with 3 ounces, right? And then we're going to have this rate, but the rate's in the wrong thing, right? Milliliters per second. Well, even though it doesn't match, we know that we need time on top. So 1 second, 0.380 milliliters. Okay, nothing cancels yet, but I've got this great piece of information to help me. So I have 29.5735 milliliters, and on the bottom, 1 ounce. Now, how did I know to write it this way instead of ounce over milliliter? And you're thinking, well, duh, because I need to cancel milliliters and ounces, and this way, milliliters cancel, ounces cancel, and look what's left. The only unit of measure is seconds. So we're almost there, right? All that's left is we need our answer in minutes. So we need one more simple conversion to get seconds into minutes. So we need seconds down here, minutes up top, and what's the relationship between seconds and minutes? Well, duh, right? 60 seconds in 1 minute. Seconds will now cancel, and now look what happens. The only units that are left are minutes. And if you do the math, 3 times 29 blah blah blah, right? Divide by 0.38, divide by 60, you get 3.89, and then your unit that's left is minutes. And it's just that simple, guys. Even if you don't remember the whole, volume equals rate times time, just start with what you have and start throwing in fractions to get rid of the units of measure that you need to get rid of, bringing in the units of measure that you need to bring in, right? So you always keep your eye on the finish line. I know that I need my answer to be in minutes, so I'm going to make these conversions to turn it into minutes. All right, how about one last example? Okay, here's one last example. We've got, we're talking about hypoxia, all right, and a biologist measures the oxygen levels in a lake at 1.76 milligrams of O2, right, per liters of water. So I know this seems really confusing in typeset. It's not easy to see. So if I write it out, it'll probably, I don't know, make a little bit more sense. So we've got 1.76 milligrams, right, of O2. So this is my unit of measure, milligrams of O2 per 1 liter, right? I'll make it LTR, so it's liter of H2O. So again, ugly, but just one unit of measure here and one unit of measure here. So it's just like feet per second, miles per hour. It's just milligrams of O2 and liters of water. Okay, so that's where we're starting. And where do they want us to go? They just want us to go to US units. So instead of milligrams, we're going to need, right, pounds. And instead of liters, we're going to need gallons. Right? So I'll even put these in colors. Yellow goes to yellow, green goes to green. And now we're not given the information. This is where we need to know the information or look it up. You know, how many liters in a gallon, how many milligrams in a pound, etc., etc. Maybe we don't have a precise conversion for grams to pounds, but maybe we have, or sorry, milligrams to pounds, but maybe we have grams to pounds. We know how many grams are in a pound. So we know that 1 pound, 1 lb, equals 454 grams. And once you have this conversion, all you need to do is get milligrams to grams and then cross the bridge over into pounds, and you're good to go. Well, luckily the metric system is pretty easy because we know it's just 1,000 milligrams in 1 gram, and then now we can use this conversion and have where do the grams go? Top or bottom? Right, they got to go down here because they need to cancel. 454 grams per 1 pound, and now we can see that the grams have canceled and the milligrams have canceled, and our units of measure are now pounds of O2 over liters of water. So now all that's left is converting liters to gallons, and we already saw from a previous example that 1 gallon is 3.785, right, liters, and the liters have now canceled, and now we're left with pounds, right? The only thing on top, pounds of O2, and on the bottom, gallons of water. You do the math, multiply, 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 divide, 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 and you get very easily 1.47 times 10 to the negative 5 pounds, right, of O2 per every 1 gallon of water. Okay. If you don't remember scientific notation, right, it's just you get a really small number because you're dividing by 1,000 here, and you're also dividing by 454. So you get a very small decimal. In fact, you get 0.12, sorry, 1, 2, 3, 4, 1, 4, 7, and some more things. And scientific notation is always you want the decimal with just one leading number, right? One leading digit. So you move it 1, 2, 3, 4, 5 times, put it there, and then that's the negative 5, because to get it back to where it was originally, you got to move it in the negative direction. So that's why it's 1.47 times 10 to the negative 5th. Okay, and that's the conversion line, guys. It doesn't matter what kind of things you're converting. It's very simple. You just, each little compartment, right? Each one of these little compartments is just a fraction equal to 1. So you always make sure that top and bottom, whatever they are, they have to add up to 1, right? 1 gram equals 1,000 milligrams. 1 pound equals 454 grams. And you put them in the right place so that your units of measure cancel, and you're left with the units of measure that you want. All right, hope that helps.